Okay, Assalamualaikum warahmatullahi wabarakatuh, and good morning, everyone. Today, I'm Nur Silviyah Rahmi from Brawijaya University. I would like to present my paper to the International Conference on Information Technology and Digital Application, or ICITDA 2022. Before I starting my presentation, I would like to say sorry because I use video to present. Uh, Please permit me to share screen my material of the presentation. This entitle of presentation of the research is multi-classification and random oversampling naive bias in imbalanced dataset, which is this case study is for early detection of cervical cancer in Indonesia. This is our uh, outline for today. The first one is introduction, and the second one is literature review. The third is research method. The fourth, result and discussion. This is the main of our presentation, and the end is conclusion. So we go on to the first outline, that is introduction. We know that classification is the process to modeling data classes and estimate of the class object. But in some machine learning, we have a data that is called imbalance data. When occur, one class has much larger number than the other class, which class minority class will classify majority class than minority class, and it will be produce a bad accuracy in prediction. And we know imbalance data is the initial detection of cancer cervix in Indonesia have properties that imbalance because we have 20 data for people who have no cancer, and the other one, 70 people that is determined as a cancer. And then we know that the urgency of this research is because from data in 31 January 2021 show that cervical cancer in Indonesia occur in 23.4 per 1,000 population in mortality rate 13.9%. So we are going to approaching sampling technique that is commonly in the machine learning. We call it SMOTE or synthetic oversampling algorithm. And the second one is random oversampling. We are want to comparing between two approaching sampling technique from imbalanced data. And this is our hypothesis. The null hypothesis is smooth naive Bayes classifier provide more optimum result. And the alternative hypothesis, smooth naive Bayes give less optimum result. And we would like to provide it in the result. This is our second outline, literature review. We know that naive Bayes classification have this equation that is NBC is the simplest probability classifier based on the Bayes theorem, and it has a high independent assumption. After we know that naive Bayes is the basic for the classifier, that we would like to splitting data for training and also testing. The cross-validation model used to compare and evaluate learning algorithm by split into training and testing. This is a picture show that we have 5-fold validation, and the blue is for the test data, and the orange color is from the training data. And we know classification method performance using confusion matrix or cross tabulation for the actual classification and the prediction class. This table show for the K classification, but in this classification, we only classify in two kind of classification. That is someone who has cancer or no cancer cervix. We have true positive and also until false negative. Now, then we have some information about cervical cancer. That cancer is condition with cell in the body is abnormal growing, and it will be occur in the cell cervix, and it will be called as cervical cancer. This is the following factor that affect to the someone who have cervical cancer. The first one is behavior, social support, and also knowledge. Okay, the third outline is research method. This is algorithm for our research, data entry, doing descriptive analysis, doing pre-processing data, classify with SMOTE, measure goodness of SMOTE classification, classify naive bias, measure goodness of with naive bias, then 10 classification with Ross naive bias, measure goodness of it of Ross naive bias, and determine which have a best classification among SMOTE or Ross naive bias. This is our flowchart, which means have the same characteristics of this algorithm. And we know naive Bayes classifier is statistical approach to classify perform that performing inductive preference. We use mixture classification using SMOTE because our majority class is 70%. SMOTE is a synthetic minority oversample technique that would like to generate minority class. So the minority class from the case will be generated. So in our case is 20 data will be generated into some data that will be have the same of the majority classes. And then the random oversampling also will be addition from the minority class to the majority class, but it has characteristic that it's random and different between random and also synthetic minority. This is our result and discussion. The first, we would like to know some descriptive statistic. Factor influence early detection of cervical cancer. From the mean, we know that the highest impact is coming from the intention commitment. So the intention commitment, and then the second one is eating behavior, and the third one is personal hygiene. That is the third factor that impact to the someone who have cervical cancer or no. And the fourth one we know from the mean of the data 9.67, that is behavioral sexual risk. Yes, behavioral sexual risk is activity that put many risks for adverse health, and the other one is something like our habit or maybe behavior eating, intention of aggregation, and so on. And we will continue to the other factor from the table. We know that the highest impact for the cervical cancer for the someone is coming from motivational strength. If someone would like uh, to be cure from the cervical cancer, that is motivation strength, and the other is social support instrument and empowerment knowledge. This is our result for the comparison of classification between SMOTE and random oversampling naive bias. We have the sensitivity that 10 to SMOTE, recall 10 to SMOTE, accuracy 10 to random oversampling, precision 10 to random oversampling, and specificity tend to random oversampling. So we have no decision for this criteria from the naive Bayes classifier, but we can continue to summarize which one have the better result, because every uh, performance have three for the SMOTE and uh, two in the random oversampling. So we can average the SMOTE classifier. So, and we can conclude that SMOTE naive Bayes classifier has the higher percentage, that is 81.73%, than random oversampling naive Bayes, which is 81.12%. This is comparing between SMOTE and random oversampling using another measure, that is AUC and ROC cures. The results show that SMOTE naive Bayes has the highest, that is 81.73%, and random oversampling is only 81.12%. So the conclusion is SMOTE naive Bayes classifier is the suitable method for classification in the case of early detection of cervical cancer in Indonesia, and the best evaluation criteria for the model is using AUC, or area under curves, and SMOTE have higher than random oversampling. Thank you for the chance for this time in the presentation in ICITDA 2022, and I'm so happy if the other one have a question for me. Thank you, and Assalamualaikum warahmatullahi wabarakatuh. Good to see you.